Bismillahirrahmanirrahim. Dear students of English version 11, Assalamu alaikum. I am Muhammad Obadur Rahman Chaudhary, lecturer in physics, Cantonment Public School and College Soitpur. Now we will discuss on a very important topics from physics first paper and chapter 5 from work energy power chapter. In our previous classes, we have discussed about the equation of work done for a constant force. Now we will discuss about the example of the work done for a variable force, and here the work is to expand the spring. For the expansion of a spring, we will find out the equation of work here, and we know when we will expand a spring from its equilibrium position to another position, when we will expand, then a energy will must store in that spring, and this energy is known as the potential energy. So you can also say this the equation will be for the potential energy for the expansion of a spring. And if you got the equation for the expansion of the spring, the equation of potential energy, then in the same way we can find out for the reduction of the spring. So now here, suppose in the figure 1 there is a spring, and the one edge of the spring is connected with a constant support, rest support, and on the another edge of the spring here has been added a mass, particular mass m, and in this figure the spring is at its equilibrium position. Now we have applied an external force on the spring F extra, and to pull out it the outward direction to expand it, and here suppose we have expand the spring in x meter from its equilibrium position. So again here, when we will expand the spring, applying the force to the outward direction, for its elasticity, spring will must create a force within it itself, and this force is known as the restoring force. Again, when we will expand the spring in the outward direction from its previous position, so now here according to the information, so if we expand the spring with an external force, the spring will create a force within itself to come back its previous position, and this force is known as restoring force. Here restoring force is Fs here, and from the basic, the restoring force will must be proportional. Stop. Now from the information of the spring, here the restoring force will be proportional to the expansion of the spring, but it be the direction of the force will be opposite direction to the expansion here. So as much as we will expand the spring, the force, restoring force will must increase here. So the restoring force or spring force will be proportional to the expansion of the spring but opposite directional. So we can write this equation, the equation of spring force here, the value of spring force. So now we will write the information. The spring force will be proportional to the expansion of the spring and opposite directional. So here we can write the equation, spring force here Fs is proportional to the expansion, and as it's opposite directional, then we will have to submit the minus. So here spring force is proportional to the expansion. Now the equation Fs is equal to minus kx. Here we know here k is a constant value, and this constant value is known as the spring constant or force constant. So here is the another important information from the student. You know, here you will must face the spring constant as a knowledge type question. What is called spring constant, and both it is important for the understand based question. So first of all, let us know how you will submit the answer what is called spring constant. From this equation you can easily submit the answer what is called spring constant. So from this equation, to expense the 1 meter length at the free edge of a spring, how much force is needed? This is known as the spring constant of that particular spring. So again, listen to me. The force is needed to expense 1 meter length of the free edge of a spring. How much force is necessary? This is known as spring constant. And from this information equation 1, you can easily see that the unit of spring constant is Newton per meter. So from here you will face another important understand based question. What do you mean by the spring constant of a particular spring for a particular value? Suppose, what do you mean by the spring constant of a spring is 2.5 Newton per meter. Here, suppose you may write in your copy as understand based question. What do you mean by the spring constant of a spring is 2.5 Newton per meter. So from here, from this equation, we can easily submit the answer. First of all, you will submit the definition of spring constant. Then for that particular spring, the spring constant 2.5 Newton per meter means for this spring to expand 1 meter length of the free edge of this spring, the necessary force is 2.5 meter. To expand the 1 meter length of free edge of that spring, the necessary force is 2.5 Newton. So here in this way you can submit the understand based question, the answer of the understand based question here. So student will must remember from the spring constant or force constant we will face two questions. One is knowledge based question, what is called spring constant, and another is understand based question. Now let us complete the equation here. So the next, as we are expanding the, so now again from the information, if we pull the spring with the external force very slowly, then there will be no acceleration, and in this case the external force will be equal to the restoring force, but it will be opposite directional. So again, if we pull the spring with the external force in the outward direction very slowly, then there will be no acceleration, and here the external force will be equal to the spring force but opposite directional. So we can write in this way: the external force will be equal to the spring force but it will be opposite directional. This is why we will submit here minus sign. Now we will submit the value of Fs here, spring force, minus kx, minus kx here. So the value will be plus kx. Now we will, so finally we have got the value of the external force here, kx. Suppose equation number 2. Now we will find out the work done for the external force here for the expansion of x here. So as the work is done is for the variable force, So we can divide the total expansion is 2 mass smallest division, and then if we take the help of integration, then we will get the total work for the expansion of x. Suppose the initial position of the spring was x1 and after expanding the final position was x2. So within this limit, if we integral, then we will get the total work for the expansion of the spring for the expansion. So let us integral the equation 1 to find out the total work. Now work will be the total work suppose W equal to integral from x1 to x2 F external force and dx here. So now let us put the value. Now we will put the value of external force here from the equation 2. From the equation 2 we will put the value integral from x1 to x2, and the value of F external force is kx here, kx into dx. Yes, here k is a constant value, so we take it outside. K from x1 to x2 x into dx here. Again, so the work W equals to k, and let us complete the integration. Here x is power is 1, so according to the formula we know x to the power n plus 1 by n plus 1. Here n means the power is 1, so 1 plus 1 by 1 plus 1. So here power will be x square by 2 here. So x square by 2, lower limit x1, upper limit x2. So here half is also a constant value. Let us take it outside. Half k and x square, and this is from x1 to x2. Now let us put the value of x, half k x2 square minus x1 square. So it's another important equation for of the work for the expansion of a spring, half k xf square x1 x2 square minus x1 square, where x1 is the initial position of the spring or length and x2 is the final position. And if we assume that the initial position or the value of x1 is 0 and the final position x2 is equal to x, then we can get another equation. Suppose if we take the value, suppose x1 initial position was 0 and x2 equal to x, then from the equation 3 we can get W equals to half k, the value of x2 is x square minus 0 here. So the equation will be, you can write W equal to half k x square. Is another important equation. So it's the final. So the final equation for the work for the expansion of a spring is, here W equals to half k x square. Here k is constant value and x is the expansion of the spring. So students will must memorize and still must remember the two important equations related to the expansion of a spring. One is half k x2 square minus x1 square, and another is half k x square. And from this information you have been clear that if we find out the work done by the external force, the work will be positive, and if we find out the work done by the spring force, then we will apply this equation. In that case will got the negative work. So you must also remember this information. So either it may be contraction or rarefaction, it may be expansion for the spring or the reducing for the spring. Work will be half kx square, but for the external force the work will be positive, and for the spring force the work will be negative. In this case, here we have find out the equation of work for the expansion of the spring, and this work, according to the information you know, this work will must store in this spring as a potential energy. On the other hand, you can also say this is the equation for a spring, equation of potential energy, how much potential energy will store in a spring for the expansion. On the other hand, we can also find out the equation of the work for a spring for the contraction. Then the range x1 and x2 will be changed. So then the value of x1 will be more and x2 will be less. So we can find out the work done for the expansion of a spring and both for the reduction of the spring. And from this information, student will must remember, here's another important topics here. One is knowledge based question which was related to the spring constant. Here, what do you mean the spring constant? And another is important understand based question on the spring constant we have already discussed. And these two equations are too much important for both SSC exam and for all the admission, especially for the university admission and for the engineering admission. So you will must, first of all, you will must practice the mathematical problem related to this equation. Then you will solve the CQ based on this equation. It will help you to take a better preparation for both SSC exam and for both the admission exam. So student, carefully will must take the lecture and will must memorize those equations, and information is also for the MCQ. So do well and get a better preparation. Thank you very much. Allah Hafiz.